Hi and welcome to my session, Designing and Scaling RAG Pipelines at SAP. So basically, I'll walk you through our journey from how we went, basically fledgling POC to production-ready pipeline using Airflow, and currently able to process millions of documents and terabytes of data. My name is Sagar, and I work as senior software engineer at SAP, and first time speaking at Airflow conference. So, yeah. In this session, basically, we'll go over why we felt the need of designing a pipeline, why we chose Airflow as our choice of framework, and what are the challenges we faced and things we built to enable vast amount of data processing for SAP and the use case behind it as well. Like what product do we power through this RAG pipeline? So going over the agenda a little bit, I'll just introduce the product real quick, which is basically Joule for consultant. And we will go over POC to production, a little bit of architecture and how we manage Airflow in multiple environments. Operators we created, services we created, experiments we went through, and some of the challenges and learning that came out of this entire development effort. So to start with, the product is called SAP Joule for Consultant. So this is basically a generative AI copilot solution for SAP, specifically focused toward SAP consultants. So let's imagine that there is a consultant named Lara, and she is implementing a solution for SAP, and she runs into like some sort of a problem to which she kind of doesn't know like the answer to. We all do that, like as developers or consultants, we usually go through this entire process of finding the solution to a particular problem, which does take time and kind of like reduces the speed of executions. That's where the Joule for Consultant comes in. So basically, any consultant working on implementing SAP solution to any vendor, they can ask any question in natural language to this copilot, and will get expert reviewed information and curated and grounded in SAP curated content at their fingertips. And we have seen like consultant productivity increase by marginal amount, like 30% or so with this. And it also has capability to write ABAP code, which also allows like faster implementation of the solutions. So basically, as we all know, like there are other solutions out there in the market as well, like ChatGPT for one, and Microsoft's Copilot, and Perplexity, and so on and so forth. But what sets the Joule for Consultant apart from all these solutions, that it's grounded in factual knowledge of SAP, which is a lot. So basically from multiple certifications, learning journeys, community posts that are authored and reviewed by experts, developer tutorials, and there is a vast amount of knowledge that SAP has. So the Joule for Consultant is grounded on that knowledge, plus it can generate well-reviewed ABAP code as well. So now to talk about the scale and the problem that we were tackling was basically kind of trying to onboard 15 plus different data sources, and each of those data sources have terabytes of data, multiple documents, and in different formats, going from PDF, Word, and Excel files to multimodal data as well, like PNGs. And one thing that is really hard to parse is that we face is usually PowerPoint slides, and most of the consultants work on those, convert those to PDFs, that sort of data. Plus also through this, we wanted to help the ML experimentation teams, like our research team. So the asset that they generate should be seamless, and if they come up with a research path, and if it performs good, what should be the path from research to production? We had to enable that as well. Also, taking care of all the GDPR compliance and removing PII information, and also keeping the content refresh all the time. So basically, one tutorial got released like let's say a month ago, and somebody made a change to it. Now the certification has like new knowledge that the copilot, the Joule for consultant has to like be on top of and be refreshed about. So to tackle all these things, like we built this pipeline. So now you guys know the context. So I'll start with where we were when we started. So initially, basically we were at POC stage, trying to present this solution in conferences, and to enable that, we were writing like back and forth multiple scripts to parse the data and push that to a vector database. If something goes wrong, some developer has to come in and like restart that script again, manually go into the cluster, check what's the status of the job, and the new data that if we get access to, or like we do have to onboard, all of that has to be like coded separately, run as a separate job, no observability, and like if something fails, the failures are cascading. And if things run and we do produce good quality of results, that data is not accessible to everyone. Basically, sharing of the data also becomes challenge. So with all that, what powers Joule for Consultant, like behind the scene or architecture? So Joule for Consultant as a bot, its knowledge is driven through this pipeline that we created using Airflow, among other services. So SAP has its own plethora of services in AI, generative AI space. So like SAP AI Launchpad, and a grounding service which provides access to vector database, and we use proprietary HANA Vector DB to store all of this knowledge, like create embeddings and store it in that vector service. And also we have an underlying database layer which tracks like how much volume of data we have ingested, what's the state of that particular data, if it has gone stale, how to refresh it. So this is like the behind the scene high level for Joule for Consultant. So why did we choose Apache Airflow? I mean, after the POC phase, like we evaluated multiple orchestrating solutions like Taxter, Prefect, and I think Flight as well, and also looked at some of the tools that we were building like kind of in-house, trying to build a pipeline through Cube events basically. So those all do work well, but we needed fast implementation, iteration, and a industry tested solution. That's where Airflow came in, and also like it has existing managed solution as well. So if in future we do need to like migrate to a managed service, like we'd had choice of Cloud Composer, Astronomer, and MWA as well. And again, the Airflow is Pythonic. Most of our team and our code base is Python native, so it's just basically plugged right in there. And yeah, also its integration with our existing DevOps infrastructure, which involves like Helm chart deploying through Argo CD and GitOps. So it kind of became like a de facto choice for us. But one point that drive everything home for us was the community behind Airflow. Like it's constantly growing. We see like how the development is ongoing development is happening for the platform. Like new features get released. Some of the pain points that we did encounter in our development efforts, I see them getting addressed during these talks as well. So that's why like we chose to go forward with Airflow. So now let's like look under the hood, like how we manage the Airflow instance in SAP's business technology platform, which is basically a Kubernetes runtime called KEDA. So we have for each deployment, we have a particular namespace. It has its own resources. We have like high availability schedulers, which currently are sitting around like 2 scheduler per instance, web server, triggers, and workers we scale based on KEDA autoscaler. And it's all integrated as backend data structure. We use SAP's BTP hyperscaler, which is like a variation of Postgre managed Postgre database. Redis for queuing system, and GitSync for feature deployment, and SAP's object storage for remote logging, and also like as an XCom backend as well. We use like Airflow's community Helm chart. Currently, we are sitting at Airflow 2.9.3. We do have like plan to upgrade to Airflow 3.0 with all its like new features. So yeah, going forward, how do we manage this entire pipeline or entire platform in production? That was one of the main problems, like how do we manage the platform itself, but the pipeline also, like how do we allow whoever's working on the features. So features are driven from research, from like ML researchers, but platform engineering happens like basically with the DevOps user or platform engineers as well. So to manage all that, we have, as you see in this diagram, like a central GitHub repository where we manage using Argo CD. We perform like GitOps and manage the platform changes and its deployment into multiple environments. So currently we are supporting one environment in development and one in staging for internal users, and for production, I think right now we're sitting at like 3 availability zones. So to manage all that, we use Argo CD and Helm chart. So it allows us to basically steer clear of deployment drift that happens. So all environments across production, staging, dev, they are all consistent. You get one feature in one, so it means like it's rolled out to all of those environments, keeping everything consistent, no matter if you are running an experiment in staging or if you are like serving users in production. Yeah, so for as I'm talking about the feature. So in the same basically GitHub repository, if there is a new feature, let's say some developer worked on a better parser for a new data that has been introduced to ingest a client or like a content LOB. So for that, like if we need a custom parser or a custom operator, that would go through the CI/CD pipeline that's managed by Azure, and it'll get reviewed by developers. We create GitHub-based tag release, which eventually gets synced in all these and all the environments that are like dev, staging, and production. And this allows us, like if something breaks somewhere in the new release, you can always roll back to the previous release as well. So in production, the pipeline doesn't break. With the deployment foundation in place, let's look at like how and what we are doing inside our Airflow DAG. So this is the current DAG architecture. So as you see, like we have multiple data sources like where we are fetching data from, be it like scraping from the internet or that is publicly available SAP content. Object storage, GitHub repositories that developers write internally and externally also. Basically, those are maintained as GitHub tutorials. SharePoint uploads by different teams who want their data to be part of the solution, that is Joule for Consultant, and want their knowledge to be grounded in the answers that it generates. And also, like there are other knowledge systems in SAP as well, which provide us data through like REST APIs, OData, etc. So so in our DAG, first step we take is basically loading the raw data. So we make sure to like persist that raw data that gets downloaded as part of first step in the object storage, so that we have like a source of truth if something goes wrong, and if we do need to like move back and reprocess it again. Then the second step is pre-processing that data. So for each of the raw data here, we clean it up, preserving the layout of the raw data, and we basically create a couple of documents for each input document in a clean format, and also like one document is related to its metadata and one is for content. The next part, we perform like advanced chunking. It's basically a few chunking techniques that are relevant to different sort of data sources that are in SAP. For example, uh, SAP community blog posts have different sort of structure that if we chunk them properly, like using whatever parameters that they have defined, they perform better in retrieval, so on and so forth with different categories. So currently, like in advanced chunking, we have these sort of multiple algorithms that anyone who wants to experiment with can just select and run them, and it creates chunks for the input document. And we persist those chunks as well. And for the fourth step, we extract the metadata per chunk basis and also serialize it. So at this point, everything in our pipeline becomes more like unified, because that's one of the problems, because you don't want to lose the structural integrity of the document that you're processing, but you do want to provide like a unified interface for that document once it makes its way to uh, the embedding and ingestion phase. So the fourth step, that is metadata extraction and serialization, takes care of that. And each step of the pipeline, we maintain like a status and progression uh, uh, progression monitoring in this data persistencies layer. So if something breaks, or if we want to uh, start another run from, let's say, an intermediate step, we already cleaned the document, but we want like a different chunking technique to be used, or some sort of another research feature that we want to apply to the clean document or the chunk itself. So the DAG run can continue like from either step 4 or step 5, like whichever suits the needs best. And in the fifth step, we basically redact all the information for for the documents and chunks, like basically removing any PII information. So because a lot of the data is public, and they have like author names in them and their personal details as well, so we don't want to ingest that. So we go ahead and redact all the PII information there. Uh, one, the next module is SAP specific, is basically how we interact with the vector DB. So for that, like we have this document grounding client, which basically takes care of creating embeddings and ingesting those embeddings in the vector DB, taking care of the embedding rate limits and the normal API rate limits, and how much data can, how many connections can we make as well. So it takes care of that. Moving on to the next step. So yeah, so basically, so all of these steps are modular tasks. They are reusable. So and I'll go over how a research like an ML researcher or a developer working on the pipeline can use these tasks to create their own runs and basically create experiments and try and improve the accuracy of the copilot that we are supporting. All of them like can be parallelly processed, and they have like comprehensive error handling. If something fails, you can restart from the previous step. Okay, so I'll quickly go over like how the tag looks like. Oh, why is it not showing? Okay, yeah. So how we started was, initially we basically hard coded like one big fat DAG. So it had like all whatever at that time the categories we were supporting. It had like processing capabilities for all those, but quickly it like went out of our hand. Like it was hard to manage, because anytime a new content LOB is coming, even though they require the same sort of processing, we were writing like another branch, like manually adding another branch to that DAG. Then we introduced configuration based on Airflow variables. So you could like define a variable, read that variable in the DAG, and basically have the same definition. And it'll just basically dynamically create that DAG and create a DAG run and process the pipeline. But then this introduced like if a developer or like a researcher or pipeline user is trying to process multiple configurations in just one file, which it was intended to do. So we ran into scale issues, basically one DAG dynamically like mapping into hundred thousands of tasks and basically choking the scheduler. And in the third iteration, we basically switched away from only relying on one DAG and allowing basically users to run the DAG using DAG parameters. And each time they can basically pass like one configuration to either like the ingestion for basically either the ETL DAG or the ingestion DAG and can run them in parallel. So this reduced like one DAG spinning into many tasks, but having parallel DAG runs instead. So here are like a couple of things that we created along the way to support this pipeline. So as I went over, like we created a chunking service operator, which basically supports advanced chunking techniques that we created in-house, metadata serializer, anonymizer operator, and evaluation as well. So whenever you ingest the new data, how you test like how the Joule for Consultant is performing. So we have operators like ragas and LLM as a judge quality scoring as part of the evaluation operator. And again, for interacting with the SAP HANA Vector DB, we created this Vector DB ingestion operator to basically take care of all the embedding model rate limits and also the how many connections in parallel can we make when we scale. And also the retry logic, if something fails, like if the embedding model crashes, how do we basically preserve that state and then in the next run, like start from where we left off. Okay. Yeah. Okay, so the another challenge in the pipeline was up until now basically onboarding the content, but how do you keep refreshing the content and getting rid of the stale content as well. So in this scenario, we basically right now do rely on monthly cron-based scheduling for Airflow. We check like at each step, as I mentioned previously in one of my slides, that we do persist raw data. So we create like a hash for each raw data. So we check and compare like if the data has changed. If so, we mark the previous one as stale, and basically Airflow takes care of running that pipeline on the fresh content. We trigger a delete event for the vector DB to remove the stale data and refresh with the new one. And for experimentation and ML workflows, the same pipeline runs, as I mentioned, like can be run multiple times with different configurations. Any ML engineer has the ability to choose multiple evaluation criteria or different chunking techniques or something that they have written. They can just onboard into that pipeline, basically quickly tweak the configuration and run the DAG, and it basically creates all the necessary assets to do like further evaluation. And if it performs better, we move things to production then. If not, then it becomes as part of experimental record for further further analysis. So here are a couple of challenges that we faced. One of the initial challenge was like when we were using just git sync out of the box, was basically like if something happens in a branch, then everything gets affected. And basically you don't have like much track of what is running in which environment, and if something breaks, everything gets affected because of it. But allowing the using the git sync tag releases, it gave us the ability to, if something does break, we can roll back always. Okay, I'm getting the time up sign. But yeah, so these are like a couple of challenges. Like basically we reduce the task fan out by using batching and out of memory issues to basically tweaking the Airflow parameters. An XCom blot that we were facing initially because we needed to pass data from one task to another. We use like object storage backend and also optimize what we are sending to the next task to reduce the XCom bloat. That's my time already. Thanks everyone.